is pattern discovery. Suppose that if you are taking any shopping transaction, in the shopping transaction, if you want to improve any profits in that, the following questions may be arised. For example, if you want to know what group of items are frequently bought together, it means that, for example, if you are buying the milk, along with milk, what is the other item that is preferred to buy? For example, if you want to buy a bread or butter, so what is the most frequently used item that is brought with the other item? That should be analyzed. And if a person is buying something, one item during any specific time, what the other item is being preferred? Here you can see that if a person is buying a diaper at night, what is the probability of him buying the beer as well? And also some of the customers who wants to buy new versions. For example, if a customer wants to buy iPhone 14 or 15, so what he'll do, he'll just wait for the versions, and once it is released, he just gets that mobile, right? So here, what are the most preferable items that customer is being waiting to in order to get that? That also is to be analyzed, and that can be done with the pattern discovery. Now, what is this frequent patterns? Basically, frequent patterns are the patterns. Here, patterns refers to item sets, subsequences, or substructures which appears very frequently in the data set. So if I'm saying that a frequent set of items, so such as milk and bread, how frequently people are buying bread along with that milk? Such sort of things we call it as what? Frequent item sets. And what is a subsequence? For example, if you are buying a mobile, later you try to prefer to buy a cover for that. Later you prefer to buy a screen guard for that. In a similar way, if you are buying a PC, then you will buy a digital camera, then you'll buy a memory card, right? So in the sequence, you'll do some sort of shopping, and that we call it as what? Sequential pattern. So we also have something called substructure patterns. What are this is? Basically, the substructure patterns, they are represented in the form of subgraphs, subtrees, or sublattices and all. So what is the substructure is? For example, if you have a social network, and frequently we'll be using or sharing our photos, or we'll frequently chat with our friends, right? So here, among the social network, the activity which you are doing, that tagging and all, it's called what? Substructure. So that substructure forms which are there, it is represented in the form of trees or graphs. So in order to detect those substructures also, we'll be using the frequent patterns. And the substructure which is being occurred frequently, those are called what? Structured patterns. To understand these frequent patterns, there is a motivating example which is called market basket analysis. Now let us see what is this market basket analysis. Before that, so frequent item set mining. So now we are talking about frequent item set mining. What does actually it mean is, it discovers the associations as well as the correlations which are being present in the database. So what are this association and correlation? We'll learn in detail. And let us come to this market basket analysis. So what actually is this market basket analysis is, if a customer is buying a milk, how likely is trying to buy the bread, or how likely is trying to buy the cereal? So all these things, all this analysis, we call it as the market basket analysis. And why actually we are using this market basket analysis? So this helps us in order to increase the sales and also plan the shelf space which is there in that market. Now, look at this. Here we have customer 1, customer 2, customer 3. In that way, some customer n data, where customer 1, when he's buying the milk, is buying bread as well as cereal. When coming to customer 2, when he's buying milk, he's buying bread, sugar, eggs and all. Customer 3 is buying bread and butter along with milk. In the same way, we'll analyze some n number of customers, and then who are the customers most likely to buy bread with milk, or who are the customers most likely to buy eggs with milk. So that analysis is made. Let us consider one more example. Like, let us take all electronics example, where we have all type of electronic devices which can be purchased. Now, when you are buying that, the analysis of customer buying habits of the customer can be analyzed in such a way that, first, which group or set of items are customers likely to purchase on a given trip to the store. So what set of customers are liking to buy which type of product? So to analyze this, we can perform the market basket analysis. And in the market basket analysis, when he is trying to buy a computer, or when he's trying to buy a camera, we can see that most of the customers are preferring to buy some memory card. So whenever the customer is buying camera, it is a possibility that the customer will also buy a memory card. So in that way, if the customer is buying some software, so suppose, let us consider that we are buying some computer or laptop. When we are buying that, most of the customers try to prefer for the software also, like they try to install the antivirus software. So now, the owner, if he is able to place the software or hardware together, then there is a possibility that customer can buy both hardware and software, which will increase his profits. So this is the way the market basket analysis is done. And when you are talking about the frequent patterns, there are some concepts which has to be known, which are called item set, support, and confidence. Now let us see what is item set and what is support and confidence. When you look at the item set, it means that one or more items which are present in your data, that we call it as what? Item set. And you can have any number of item sets. And what is the support is the frequency or occurrence of that item. How many times the item is being occurred in the transaction, that we call it as a support. Now, we also have confidence. Then what is this confidence is? If there is an item which is called X and Y. So what is the probability that Y will be occurred in the data set where X contains? That we call it as a confidence. So let us understand this. Here we have an item set. So what is the, suppose, let me consider, I want to know just how many people wants to buy beer with nuts. To know that, here X is considered as what? Beer, and Y is considered as what? Nuts. So the integration of beer and nuts, how many times it is repeated? We can see in this example it is repeated only once, right? So only one customer is preferring to buy that. And if we are talking about the confidence, when you are talking about the confidence, means how many times beer is repeated in this transaction. You can see 1, 2, 3 times, right? Among those 3 times, how many people are preferring to buy beer along with nuts? That will give you as the confidence. So here we'll have minimum support as well as minimum confidence, so which we'll learn in detail with the association rules. Here, what is association analysis and what is this association rule mining? So basically we know that what is meant by association. When those 2 points come together or have similar properties, then we call it as the association. And here, what does the association do? It discovers the probability of occurrence of items. How many times that items is being repeated in this data set. That can be known by this association. And also it shows us the relationship between those items which are there. So if you see that those who people are buying milk, there is a possibility of that most of them will buy bread, right? So there is a strong association between this items, milk and bread. And basically we apply this on the data set which consists of object. And this object, we know that every data object is made of some set of attributes, which we call it as the dimension or features. Now what are features is, this features represents height, qualification, color, etc. and all. So now, based on this data, we need to mine the rules. So what is the association rule mining is? It makes us to find the interesting associations and relationships which are there among large set of data items. So if you have any large set of data items, in that large set of data items, which items are mostly associated together? How frequently that item sets are being associated? How frequently that item sets are being used in the transaction? That can be known by the association rule mining. Now, let us look at the example of market basket data. So this is an example which consisting of 6 transactions. And for the first transaction, we can see milk, bread, rice, and book is purchased by in the transaction ID of 1. In the transaction ID 2, bread, jam, book, pen. In this way, in the 6 transactions, there are items that has been purchased. And if I want to know how many people have purchased milk along with bread, I will just make a rule that milk, how many people have purchased. Next, book with pen. In a similar way, there are different associations. If you are buying laptop, there is a possibility that most of the people will buy mouse, floor stick, floor cleaner, dishwash liquid, scrubber. In this way, we'll generate all different rules. So look at this example here. 1 represents that in the transaction ID of 1, the milk is being purchased. Bread, here it is 1, it means that in the transaction 1, bread is purchased. If nothing is represented, it means that in the transaction ID 1, it is not purchased. The similar way for all the transactions. So here, whatever the item set that are created, frequent item sets, that can be created in 2 item set, 3 item set, or n item set. So if I want to find two item sets, so this is a transaction one, this is a transaction one. In this transaction, we have milk and bread, right? So milk and bread are the two things which are there in the transaction ID. So this will form a two item set, two frequent item sets. In a similar way, when you look at the second transaction, in the second transaction, you can see that this bread action. If you want to I Hello everyone, welcome to the session of data mining. In the previous video, we have seen what are different frequent item sets. So how to form two item sets, three item sets and all. Now let us learn about support and confidence and let us know this with an example. So what is support? Support is used to measure how frequently a set of items occur in total number of transactions. In whole transactions, how frequently the set of items occurs. That can be known by the support. So let us consider two item set where it consists of milk and bread, right? So here milk refers to what? X and bread refers to Y. Suppose if you are having three item sets like milk, bread and jam. Here X refers to milk, bread and jam refers to Y. So now we can calculate the support for this milk, bread and jam or any other item sets that are present. Here X and Y refers to what? The item set, number of item sets which frequently occurs in the transaction. And what is n? The number of transactions that are present in the whole data or data set. We call it as we get it through the n, right? So now let us see what is confidence. Similarly, we'll find the confidence. So what is confidence is how often items in Y appears in transaction which contains X. So here I have the item set as what? Milk, bread and jam, right? So among the whole transactions, how many times milk is observed, and wherever the milk is present, how many times bread and jam are appeared. So that we will give you the confidence. Now let us understand that with an example. So before that, we need to know about the association rule mining. Now whatever the support and confidence we get, that should be greater than or equal to the minimum support value or minimum confidence value which is given. So if the support and confidence values are greater than or equal to that minimum support or minimum confidence, then only we can mine those data items. So let us understand this with an example. So consider these transactions. Here we have about 6 transactions, and these are the items that are there in each transaction. Now I just want to find out whether rice and eggs can be mined together as a rule or not. So for that, here it is a 2 item set, and this rice can be considered as x and x can be considered as what, y. Now I need to find how frequently this rice and x occurs in the transaction. So here you can see rice and x 1, 2, 3. So it is occurring 3 times. And then how will you find the n number of transactions? Total number of transactions are here. How many? There are 6 transactions. So now 3 by 6 will get the value as what? 0.5. In the same way, we have to find the confidence, right? So among those, what is the x value here? Rice, right? How many times rice is being repeated here in the transaction? 1, next 2, 3, and then 4. So it is repeated for 4 times. And among this, what are the combination of x and y with respect to rice, right? So then you'll get it as 3. What is the total value that you get for the confidence? It is 0.75. And here it is supposed that minimum support value is what? 0.3. Minimum confidence value is what? 0.6. Now the support value which we got and the confidence value which we got, they are greater than the minimum support threshold. It means that we can just mine this rice and x as a rule. Similarly, you can do it for milk bread, you can do it for jam book, or you can do it for book pen. So then we'll know whether we can mine those items as a rule or not. So this is about the support and confidence. Now let us see the association rule mining. So when we want to rule the association on the frequent item sets, this generally is done in 2-step process. The first one is the finding all frequent item sets, and second one is the generating association rules from the frequent item sets. And when you are having all frequent item sets, that can be obtained through the algorithm which is called a priori algorithm or frequent pattern growth algorithm. Now then how to get the association rules? That will get from the confidence, and also finding that through minimum support and minimum confidence, whether it is satisfying the rule, that is it should be greater than or equal to the minimum support and minimum confidence. Based on that, we can generate the association rules. Now sometimes even if we are having this support and confidence also, sometimes they may mislead us. So it may not be the strong association rule, but it uses that it's a strong association rule. Let us understand this with an example. Here is an all electronic example where it consists of computer games and videos. So here it is given that of 10,000 transactions, it means n is what here, number of transactions are 10,000, and the data was shown that 6,000 of the customers were interested in buying the computer games. 7,500 customers were interested in buying the videos, and 4,000 were interested in buying both computer games and videos. Now here it is shown that most of them were interested in buying only the videos, not the computer games, right? Now let us find out the association rule for this, and also it is given the minimum support as what, 30%, and minimum confidence as what, 60%. When we calculate the support and confidence for this, so the minimum the strong association rule which we get is here support as the 40% and confidence as what, 66%. Computer games, right? Now let us find out the association rule for this, and also it is given the minimum support as what, 30%, and minimum confidence as what, 60%. When we calculate the support and confidence for this, so the minimum the strong association rule which we get is here support as the 40% and confidence as what, 66%, right? So and here the minimum value is what, 40 and 66 it is given, and whatever the support we got it also 66%, right? So which is actually greater than the threshold given. Here the threshold is what, 30% and 60%. So whatever the result we got, it is greater than this threshold. So we can say that we can mine the strong association rules from this data set. Data frequent item set. But the thing is, when you look generally at that transactions, it is shown that videos can be bought without the computer games, right? So it means that they are negatively correlated. Those who buy computer games need not to buy the videos, right? So now, but for the computer games and videos, it should be negatively correlated. But according to the support and confidence, it is saying that they are positively correlated. It means that they have strong association rule. And in order to overcome this sort of misleads, we need to use the correlation. So along with support and confidence, we also use the correlation in order to derive the correct results. Now, so as the support and confidence is unable to provide the interesting association rules, so then we include the correlation into it. And there are many ways to perform the correlation measures. And among those, we are going to learn about the lift and chi-square correlation. Now let us see what is this lift correlation. So here, the lift correlation says that the occurrence of any 2 items, along with that, the occurrence of the independent items is considered. So when you look at this example, you look at this formula, you can understand. Probability of A union B means what? This A and B are the item sets. How frequently this combination of item sets is occurring, that by how frequently the independent items are being occurred. Like probability of A, how many times it has happened, and B, how many times it has happened. That should be known. So after finding this, if you are getting the value less than 1, then we say that the occurrence of A is negatively correlated. What is meant by negatively correlated? It means that the 2 items are not having. Suppose one increases, the other decreases. If one decreases, the other increases. When there is a negative correlation, right? Now, if the resulting value is greater than 1, if it is greater than 1, then we say that A and B are positively correlated, and any change in one implies the other. If the resulting value is equal to 1, if the value is equal to 1, then we say that they are independent and no correlation between those item sets. Now, Let us understand this with an example. So previously, whatever the example we have taken, the same example is here. The probability of game 60%, purchasing a video is what 75%, and the both game and video is what 40%. Now we are calculating that using the probability of A union B by probability of A into probability of B. Here A and B are what? The item sets. Now here, when you calculate the probability, you can see that you got the value as what? 0.89. So when the value is less than 1, it means that there is a negative correlation. That's the thing which we need to get. But when you are using support and confidence, what we are getting? We are getting it as a strong association rule that they are very frequently brought together and all, right? So to overcome those problems, we can use this correlation analysis where it gives the exact result of the frequent item sets. So here, it's telling that it's a negatively correlated. So such sort of negative correlation cannot be identified identified by what? Support and confidence framework. Now, this is about the lift. And we also have another correlation measure, which is called chi-square measure. This we call it as a chi-square. And to compute this chi-square, we just consider the observed values and expected values. And we also take the squared difference between these observed and expected values, which are represented in the form of contingency table. So now let us understand this with an example. Here you can see this is a table which consists of the details, like whether video is brought or whether a computer game is brought and all. So when you look at this, the people with who are the 4,000 observations show that they bought video as well as game, right? The people 3,500 customers brought only video, not the game, right? So from this table we can understand in that. Now this is whatever the given, that is called observed values. Now we need to calculate the expected value. Then how to calculate this expected value is, for example, for the game, I want to calculate this for the both video as well as game, right? So what is the sum of the rows here? 7,500, right? So what is the sum of column here? 6,000. And what is the total number of transactions? 10,000, right? When you do this, you'll get the expected value for this video along with game, right? That is 4,500. In a similar way, if you want to find for video without the game, the customers who brought the video but who did not brought the game. So how many customers are there here? 3,500 total, which are present in game also. It is about what? 7,500. And just consider the column. It is what? 4,000. 7,500 into 4,000 by number of transactions, that total number of the values, that is 10,000, right? So you'll get the value as what? 3,000. In the same way, we need to calculate for the other values also, like without video, only game which is purchased, neither video, neither game which is not purchased. So these are the results which we get from this contingency table. So now we have observed values as well as the expected values. So by the chi-square test, so this is the formula to calculate the observed chi-square value. So here we know about observed values and we know about the expected value. So suppose if you want to find for the first data item, so for that we'll be calculating using the observed value and expected value. Next for the next data item. So all the summation and the squares give you the value will get some value by after the calculation. So here the value we got is what? Some 555.6. This value is what? It is greater than 1, right? And we also seen that the expected value is more than the observed value. When you look at the video and game which is brought together, there it is given the 4,000 as the observed value, but the expected value for that is what? 4,500. So it was more. It was more. Expected value is what? More. So by this we can say that it is negatively correlated. When Hello all, welcome to the session of data mining. In this session, we are going to learn about the frequent item set mining methods. So the frequent item set mining methods include a priori algorithm, frequent pattern growth algorithms, and also the ECLAT algorithm. So in this session, we'll cover the a priori algorithm. This a priori algorithm was proposed by R. Agarwal and Srikanth in 1994. Generally, this involves join step and the prune step. Whenever we find the frequent item sets, they are joined together, and those item sets, count of those item sets is compared with the support count, minimum support count. If it is less than the minimum support count, those item sets are pruned. Basically, the a priori algorithm will start level wise and creates the candidates and then performs the test on those candidates which are generated. A priori pruning principle. If there is any item set which is not frequent, then those item sets are not considered. And a priori property. If there are any non-empty subsets which are present in the frequent item sets, definitely they should also be frequent. So a priori algorithm, it was the first algorithm which is proposed for the frequent item set mining. And here the item which is there in the transaction, it is said to be non-frequent if the probability of item is less than the minimum support threshold. And whatever, if you are considering two items, the probability of the combination of those items, if it is less than the minimum threshold, then we say that those two items are not frequent. If an item value which has taken, if it is less than the minimum support, if there are any supersets of that item also, then we just ignore those items and remove from the transaction. This property, we call it as a anti-monotone property. Now let us see how we work with the a priori algorithm. Here, in a priori algorithm, we have sequence of steps that are to be followed. So here, first we suppose just consider that we have a transaction list where we have the number of items as I1, I2, and I3. So now first we need to find out the one item set candidates. So here I1, I2, and I3. These are called one item set candidates. How many times I1 is repeated in the transaction? How many times I2 is repeated in the transaction? How many times I3 is repeated in the transaction? Let us consider that this is 3, 4, and 1. And let us consider that minimum support count is some 2. Now we need to compare this items which are generated with the minimum support count. Here, this count is what greater than the minimum support count. 4 is greater than the minimum support count. Then these two items are taken as a frequent item set. And this I3, it is having the value which is less than the minimum support count. So this item is pruned from the transaction. The same thing in the next step. For the second step, you'll consider the two item set candidates. So it means that I1, I2. Here in this example, you'll get it as I1, I3 or I2, I3. So these are the possible item sets that can be formed with the two item set candidates, right? So now I1, I2, whether this I1, I2 is present in the transaction or not. If it is present, what is the count? I1, I3, what is the count? I1, I2, I3, what is the count? Again, you'll compare this with the minimum support count. If this is greater than or equal to the minimum support count, those items that is considered, or else those items are removed from the transaction. Similarly, we'll follow the same thing for the step 3, where we'll create the three item set candidates. So instead of considering the two item set, here we'll consider the three item set. And whatever the output we got, we just compare that with the minimum support count. If it is satisfying the condition that it should be greater than the minimum support count, those items are considered. Or else the other items will be removed from the transaction. So in this way, we'll continue with the creation of item sets. And if there are any subset which doesn't meet the minimum support criteria, then the algorithm will stop working. Operations. Now let us see how all this works with a numerical example. So look at this transactions. It consists of some 10 transactions, and each transaction has some list of items. And also we have minimum support count is as what 2, and minimum confidence as what 70%, right? So using this, now we need to generate the association rules. According to the a priori algorithm, the first step is to generate the first item frequent patterns. Now, when we look at this example, what are the item lists that we have? I1, I2, I3, and I4. So we have I1, I2, then I3, right? And we also have I4 and I5, right? So these are the item lists that are present. Now we need to find out how many times I1 is repeated in the transaction. So how many times I1 is repeated? 1, 2, 3, repeat 5. Now we need to compare that with the minimum support count, right? So look at this example. Here in this table, we can see how many times the support count is repeated. I1 is for 6, I2 7, I3 7, and all. Once you found this support count, now we need to compare that with the given minimum support count. So given minimum support count is what 2. So every item set is having the count value which is greater than 2. It means that all the values or all the items can be used for the mining the association rule, right? So now we have created the one item set frequent pattern. Next, we need to generate the two item set frequent pattern. So how to generate the two item set frequent pattern? Here, when we want to consider the two item sets, so here we'll consider it as, so I1 here, I4, I1, I5. Once it is 2, next we need sections. So let's say to how many times it is repeated? 1, 2, 3, 4. So I1, I2, it has a count of what 4. I1, I3, it has a count of what 4. Now the item set which is generated, if it is less than the threshold value, that is less than the support threshold value, then we'll prune that items, right? So here what are the items which are less than the support count value? I1, I4, and then I3, I4, and I4, I4. All these steps were removed. All these items were removed from the list. Now the items which are greater than the support count, those items are listed. In the next step, we need to create the three item set frequent patterns. In the similar way, we'll consider I1, I2, I3, the three items. Here, considerably, and I will one to compare those. Once you get this count, you can see that I2, I3, I4 it is 0, and I2, I3, I5 it is 1, I2, I4, I5 we are getting the count as what 0. When it is compared with the minimum support count, that is 2, these item sets are less than the minimum support count. So what we need to do, we need to prune all these items. Now we'll consider only the first three items which are supporting the support count, right? We have now I1, I2, I3. Now what we need to do, we need to create the four item set frequent pattern. When you want to create the four item set frequent pattern, what it will have? 1. But what is the count we need to have? So simply can return it as I1, I2, and I5, right? Using this now we'll derive the association rules based on the confidence, okay? Using this now we'll derive the association rules based on the confidence, okay? So to expand this rule, I1, I2, I5, how you can expand the rule is, when you take this I1, I2 as 2, I2, and I1, I2, I5, I1, I2, I5, right? So this you simply can return it as I1, I2, and I5, right? Using this now we'll derive the association as I1, I2, and I5, right? Using this, now we'll derive the association rules based on the confidence, okay? So to expand this rule, I1, I2, I5, how you can expand the rule is, when you take this I1, I2 as two items, this can derive this other item, that is 15. Sorry, I5. Next, I1 and I5, which derives the I2. Next, I1, when you're taking only one item, it can derive the I2 with union of I5. So this we have earlier seen that how to calculate the confidence, right? So here, let us consider that. Suppose if you're taking the first one, let us consider this I1 and I2 as what? A. I1 and I2 as what? X, and I5 as what? Y. So if you want to find out the confidence, we'll be finding like probability of or summation of X union Y by summation of X, right? What is X here? I1 and I2, right? So I1 and I2. What is the X union Y? Summation of all this I1, I2, I5. I1, I2, I5, right? Now we'll go to the transaction and find out whether I1, I2, I5 is present in the transaction or not. If it is present, how many times it is present? So it is given that it is present at 2 times. Then we'll check for the I1 and I2. How many times it is present? The limit will be X and I2, I5 will be Y. The same thing, right? I1, I2, I5 by. You will check whether how many times I1 is repeated, right? So if you know that, if you are able to find that, you'll get the values like this. So I1 is found in the data set 6 times, right? And support count, and to do this, you'll get the minimum confidence value. Those are considered. This and this. These three association rules are considered. Those are eliminated. Minimum. Let here even I1 will likely will go then and will the execute try to not satisfied. I through I5, right? So this you simply can return it as I1, I2 and I5, right? Using this now will derive the return I3 and I1, I2, I5, I1, I through I5, right? So this you simply can return it as I1, I2 and I5, right? Using this now will derive the association rules based on the confidence, okay? So derive the return it as I1, I2 and I5, right? Using this now will derive the association I1 two items. This Hello students. In this video, we are going to learn about the frequent pattern growth algorithm. In the previous video, we have seen about the a priori algorithm. There are few drawbacks in a priori algorithm. If you have large databases, there is a need to generate multiple candidate sets. When you to build the candidate sets, we need to repeatedly scan whole database. This makes the algorithm slow. In order to overcome this drawback, a frequent pattern growth algorithm was developed. When compared to the a priori algorithm, this frequent pattern growth is considered to be an efficient one, which generates the frequent patterns using a tree structure. Let us see how does this FP growth algorithm works. Initially, it scans whole data set and then finds what are the frequent items in the data set. For example, if your data set consists of items like A, B, C, and D, then it finds how many times A is repeated, then how many times B is repeated, C and D are repeated. And if the count of A is 5, B is 2, and B is 1, and C is 3, D is 2, then it places all these items in a descending order. So A is having the highest frequency count, so it is placed first. After placing it in a descending order, again the database is scanned and a frequent pattern tree is generated. Now let us understand this with an example. Here you can see an example which consists of transaction ID and also the items that are there in this transaction. So here TID refers to all the transaction and here items refers to the items that are there in the transaction. So initially what we need to do, we have to scan whole database. And here the minimum support count is given as what? 3. So for example, the first step is to find the frequency of items that are there in the whole data set. It means that what is the A frequency in the whole data set? Count it in the whole transaction. 1, 2, 3. So A frequency count is what? 3. Similarly, we'll find out for C. Similarly, we need to find out for D, F, G, and all. And here the minimum support count given is what? 3. Let us assume that A is having the frequency count as 3. Now count for B. What is the frequency count for B? It is 3. Check for D. What is the frequency count for D? It is just 1, right? So it means that D is having the frequency count which is less than the minimum support count. When it is less than the minimum support count, we need to eliminate this item, right? Only the items which are equal to or greater than the minimum support count is considered. Now let us see in the next step. Here you can see the items and the frequency count for each item. So if it has 4, C, 4. The items which are having the frequency count less than the support count, they are eliminated. And these are the items which are there. Now, after eliminating the items which are having the less support count, the remaining items are to be placed in the descending order. Here, if it is having the highest frequency count, so it is placed first. We have to do the same for all the transactions. Whichever the element is having the highest frequency, that is placed first when compared to the elements with the lowest frequency count. Once it is done, now you can draw a frequent pattern tree. And initially, this tree starts with the empty node. And here, when we take the first transaction, what is the first element which is there in the first transaction? It is F. So initially it starts with the null node. Then we have here F. So let us consider this F is repeated for the first time, right? Next, after F, we have C. So this node, after this F node, will have a node which is called C. Similarly, we'll do it for A, and then we have M, and then we have P, right? So this is the path which is created for the first transaction, right? In the same way, we have to create for the second transaction. In the second transaction, you have FCABM, right? FC is already present, right? In this tree, you can just make this F as 2. C is already present, again it becomes 2. And A is already present, now it is 2. But we don't have B here. So a B node is created here, and the B node, now it will be what? Count as 1. So because we are using it for the first time. Next, we have M, but there is no path for B to M. So create a path for M here. So now the path for M and the count of M will be what? 1. These two transactions were completed. Next we have F to B, but we have the node F, so you can make it as 3, but we don't have any node here. So create a node B. C, E, and F repeated will be M conditional tree. So now we are creating the conditional pattern base based on the tree which is generated. This is the conditional pattern base. Let us start with the leaf node. So what are there in the leaf node? We have nodes like P and M, right? So let us start with the P. For the P, what are the paths we have? F, C, A, M, right? And we have one more path also for P, which is called C, B, right? So these two were considered. And when you take F, C, A, M, what is the frequency count we have for P here? That is 2. So 2 should be mentioned here. And what is the frequency count when you take for C, B, P? 1, right? So 1 is mentioned here. In a similar way, we'll next move to the next node, which is M. So M is having two paths. FCA. Here there is one path, and we also have FCAB. When you take FCAB, what is the count here for M? It is 1. So FCAB, the count will be written as 1. And for FCA path, the count will be written as 2 because M is having that count. Next node is what? B. So similarly for B, here you can see B is repeated 3 times. So it is having 3 paths. So consider FCA as one path, and the value of B here is what? 1. Similarly, F to B, so only F is considered here, and C to B, only C is considered. So you'll have 1 value for each path. Next, similarly for A, C, and F. F it is a starting node, so it is starting from the root. So the conditional pattern for that node will be null. Now, using this conditional pattern base, so now we'll create the conditional frequent pattern tree. So we have seen that F, C, A, M, and C, B. These are the paths for P, right? Just look at here. So this is the P path, and it is having F, C, A, M, and it is having one more path which is called C, B. So now you'll try to find out the frequency of each one. So F, when you look at this, what is the frequency of F here? 2, because it is not there somewhere else, anywhere else, so it is having the frequency 2. Now count for C. What is the frequency here? For C, here it is 2, and here it is 1. Total the count is what? 3. And count for A, the frequency is what? 2. And the M is having the frequency as what? 2. And the minimum support count count given here is what? 3, right? So when the minimum support count is 3, you can see all the elements were eliminated from this except the item C, because it is satisfying the condition of minimum support count, right? So only C is considered here. Similarly, we'll go for the next item M. So we have the pattern basis as FCA and FCAB. So F, it is repeated how many times here? 2 times, and here 1 time. So the F value is what here? 3, right? And when you take C, here it is repeated for 2 times, and here it is repeated for 1. So the F value here is what? Sorry, C value here is what? 3. Similarly, A is also repeated for 3 times. When you consider here B is repeated only for 1 time, and it is not satisfying the condition. So this B is eliminated, right? So now FCA is considered. Next, when you go for the item B, here any of the item is not repeated or not satisfying the support count. F is repeated only 2 times, C is repeated 2 times. A generate the frequent pattern rule. From the frequent pattern tree which we got, now we can generate the frequent pattern rules using this pattern tree. Using this conditional FP tree, we can generate the frequent patterns. When you look at the first node P, what is the frequent pattern tree it is having? So it is having a item C with a frequency 3. So C and P are the frequent patterns that are generated. And here, when you look at the next item, we have the conditional FP tree as what? FCA, which are repeated for 3 times, right? So you can generate the different patterns using this. So F2M will be one pattern, combination, and FCM is possible, FAM is possible, and CM is possible, right? So these are the frequent items that are generated using this conditional FP tree. As we are having null in the conditional repeated, no frequent patterns are available for the item B. When you take the item E, it is shown that when the item A is considered, F, C, and combination of FC are the frequent item sets that are considered. So look at C. Here we have F, only one frequent item set, that is F. So only that item is considered. So in this way, frequent patterns were generated using the conditional pattern base as well as the conditional FP tree. This is about the frequent pattern growth algorithm. Thank you. Hello students. In this video, we are going to learn about the ECLAT algorithm. ECLAT refers to the equivalence class transformation algorithm. The a priori and the frequent pattern growth algorithm, which we have seen in the previous video, uses the horizontal data format, whereas this ECLAT algorithm uses the vertical data format. And it uses the depth first search algorithm. And in this, each item is stored along with the transaction ID. And it counts the number of transactions for each items in order to find the frequency of the transaction. And let us understand this with an example. Here, this dataset consists of 9 transaction IDs and also the items which are there in the transactions. Along with that, the support count and confidence were given. Support count is 2 and the confidence is 70%. Now we need to generate the association rules using the ECLAT algorithm. So here we have the transaction and the list of items. First, we need to create the one item set in the vertical data format. For that, you need to identify what are the different items which are there in the data set. When you look at this data set, we can see that there are items like I1, I2, I3, I4, and I5. So now we need to find each item, how many times it is repeated in the different transactions. Look at I1. I1 is repeated in the transaction T1, T4, T5, T7, T8, and T9. Similarly, we need to find for I2. I2 is there in the transaction T1, T2, T3, T4, T6, T8, and T9. And next, we need to find for I3, and we need to check the database how many times it is repeated in the transaction. Similarly, I4 and I5, how many times they are repeated in the transaction. And those transactions should be listed here. And when you look at the count of these transactions, all the count is greater than the minimum support count. The minimum support count given here is what? 2. All the transactions are satisfying the condition. So we can consider all these items. In the next step, we need to create the 2 item set. To do that, for first item set, the other item set is intersected. So here, along with I1, the combinations of different item set, possibilities of different item set is considered. That is I1, I2, I1, I3, I1, I4, I1, I5. Similarly, I2, I3, I2, I4, I2, I5. So now we need to check I1 and I2, how many times it is being repeated in the transaction. So look at the database. When you look at the database, you can see I1, I2 is there in transaction 1, transaction 4, and then transaction 8, transaction 9. Similarly, we need to find for I1 and I3. Next, I1 and I4. After finding for all the 2 item sets, now we need to consider the count of each item set. When we go for the count of each item set, I1, I2 is repeated for 4 times. I1, I3 is repeated for 4 times. I1, I4, it is there in only one transaction. Here it is 2 transactions, 4. And next we have 2. And here it is 2. And here we have only, there's no transaction which is where the I3 and I4 item sets are available. And we have I3 and I5 as only one transaction, right? So now the item sets which are not satisfying the support count condition, they have to be eliminated. So this item set which is less than the support count, I1, I4, and then I3, I4, I5, I1, I4, I3, I5, I4, I5, all these items prone. Now we need to create the intersection of two item sets. So when the possibility of combination will be like I1, I2, I3, I1, I2, I5, I1, I3, I5. Now we need to check in the database where this I1, I2, I3 is present, right? Find out for I1, I2, I5, I1, I3, I5, and then we need to compare this with the minimum support count. If that is not satisfying, we'll eliminate those items, and the items set which is satisfying the condition will consider the item set, right? Now we need to create the 4 item set by intersecting the intersection of the 3 item sets, right? So when we consider I1 and I2, I3, I5, this is the database. This item set transaction is present in only one transaction, that is PI, right? So, but if the count of the transaction is 1, it is not supporting the minimum support condition. For that reason, we'll stop our a priori algorithm here, and we'll consider I1, I2, I3, and I1, I2, I5 to generate the rules. And now, given confidence as what 70%, now we need to generate the association rule. So here, 70%. Now we need to generate the association rule. So here, I1, I2, I5. So to find the confidence, we need to consider the combination of I1, I2, I5 in the data set, and with the frequency of occurrence of I1 and I2, right? So when we look at the database, we can see that I1, I2, I5 is repeated for 2 times, and I1, I2 item is repeated for 4 times. In this way, we'll be calculating the confidence will be 100%, right? This ECLAT algorithm uses the depth first search concept. Instead of finding the frequency of items, it finds a item which is there in the different transactions. It goes deeper into the transactions and identify whether the item set I1 is available in the transaction. So it's like the frequent pattern generation algorithm. It also takes very less time as it does not involve to repeatedly scan whole database. And here, but the ECLAT algorithm is suitable only for the small data sets. If your transaction ID is more, then we need to store large candidate sets. And also it takes much time to intersect all the items together. with the minimum support threshold. And if that count is greater than or equal to minimum support, then only those elements are considered as a frequent subsequences. Here, to know about the frequent subsequence, just consider this sequence where it has an elements A, B, C, A, C, D, C, F. So these items are where the just like the transactional database, here also we will have the minimum support threshold, and the frequency count of each element is compared with the minimum support threshold. And if the count is greater than or equal to minimum support, then only those elements are considered as a frequent subsequences. Here, to know about the frequent subsequence, just consider this sequence where it has an elements A, B, C, A, C, D, C, E, F. So these items are placed in this order. Now, when you look at that, you can see some of the elements are placed in brackets and some of the elements are placed without the brackets. So if any element is placed within the brackets, it means that they come under the same sequence. If it is represented without the braces, it means that the A can be in one sequence and B can be in the another sequence. So let us understand this with an example. I just want to find out AB of C, whether it is a frequent subsequence of given database or not. So for that, first initially I have to check for AB, then I have to check for C. When you look at this, AB belongs to same transaction, or sorry, same sequence, and C should be in the different sequence. Now look at the first sequence. We can find AB in the one sequence and C in the another sequence. Now the support count starts here, and now the support count will be what? 1. When you look at the second sequence, there is no AB here. When you look at the third sequence, we have AB in the same sequence and C in the different sequence. Now the support count will be increased and it will be what? 2. And in the fourth sequence, we don't have AB, right? So now the support count value is what? 2. And this support count value is compared with the minimum support count. And it is satisfying the condition, it should be greater than or equal to the minimum support count, right? So we can say that this AB of C is a frequent subsequence. In a similar way, if I want to find out EG in the database, E can be in the different sequence and G can be in the different sequence. Now, let us look at the first sequence. We don't have any EG here. In the second sequence, we have E, but there is no items after the E. And here in the third sequence, we have E, but there is no G, right? Here we have EG, and the support count here is what? 1. It is less than the minimum support count. So we'll eliminate this sequence. In this way, we can find all the frequent subsequences that are there, right? So let us understand clearly this with the different algorithms. So sequential pattern mining has different algorithms, and among those generalized sequential pattern mining is also the one. Initially in this GSP, first the database is scanned for the candidate of length 1, and after finding the length 1 candidates, then it is repeated for the k+1 sequences. So before this, after finding the length, we need to find the support count. If it is satisfying the support count, then those sequences are considered, or else the other sequences will be pruned, just like the a priori property which we have seen in the earlier videos. And we will just follow the steps until there is no frequent sequence or no candidate which is found. So let's understand this with an example. Here we have the sequences and its ID, right? As I told you, if any sequence is represented within the braces, it should be in the same sequence, or else we'll represent that in the different sequence. Here the minimum support is given as what? 2. And now we need to find the one length sequence. So for that, initially identify what are the different elements which are there in this sequence database. Okay, so we have here elements from A to G, and after that we need to find the frequency or the support count of each element. So here if I want to find the support count of A, in the sequence 1, A is repeated 1, 2, 3. So the support count is for 3. If you want to find for the support count of B, 1, 2, 3, 4, right? So it is repeated for 4 times. In the same way, we need to find for the other elements. And now we need to compare this with the minimum support count. When we look at this one line sequence support, all the elements were satisfying except the D, because it is having the less than the minimum support count. So this element will be proved. And after this, we need to join the L1 with L1. And to do this, here we'll have two cases where we, if X and Y are the two elements, X will be in the different sequence and Y will be in the different sequence. And here, if they are mentioned in the same within the braces, it means that they'll be in the same sequence. Let us see that. So this is the one line sequence after eliminating the element which is having the less minimum support, and then we need to create the two line sequence. So to create the two line sequence, we need to create the two line sequence for every element which is present. So now let us start with A. So we are finding two line sequence of A. So A is now compared with B. So AB, AC, AE, AF, AG, and then we have to create two sequences, right? One with different transactions and one with the same transaction. So if they are there in the same between the braces, it means that they are in the same transaction. Now, how to find the support count of this? So here initially we have A, B, right? So it means that A can be in one transaction and B can be in the other transaction, right? So here A is in one transaction and we don't have B here. And here A is in one transaction, B is in one transaction. So support count, sorry, it is sequence actually. So it is what? Support count is what? 1. So here A is in one sequence and B is in one sequence. So the support count is what? 1 plus 1, 2. So the total support count for A, B is what? 2, right? So here, and the minimum support count given is what? 2. And it is satisfying the condition that it should be greater than or equal to 2. So we can say that AB as a frequent subsequence. Similarly, if you want to find out for A comma B. So A comma B, they are there in the braces. It means that they should find in the same sequence. So here we can see A comma B in the same sequence. And when you look at the whole database, we can see here the A comma B in the same database, right? So now the count of this A comma B will be what? 2. So this also is satisfying the minimum support threshold. So this A comma B also can be considered the frequent subsequence. So here all the elements A, F, E, A, G, all these two-line sequence are considered to be frequent subsequence except this A comma C, A comma E, A comma F, A comma G. All these are not satisfying the minimum support threshold. So all these elements will be eliminated, and then we'll create this sequence for the two-line sequence. So this is created only for A. Now we need to create for the other element B, C, E, and all. So let us see that. And here, whatever is there, if we have A, B, it means that A is in one sequence and B is in one sequence. If you are writing B, B will come first, then A will be the next order, right? When it is A, B will be the first order and B will be the next order. So these are not equal. But when you are representing that in the braces, they will come to same. They will be in the same sequence. So it means that A comma B or B comma A, both are equal. And now, so finally, the one line sequence is this, which is obtained. Next, for two line sequence for A, similarly, you need to find out for B. As I told you, A comma B is not equal to the B comma A. Here, B, A will be the next sequence. Next, B, C, B, E, B, F, B, G. But we did not find B comma A. Why? Already A comma B is present in the two-line sequence of A. So if they are present in the same sequence, there is no need to write it again, or it will not be repeated, right? So in the same way, we'll create for the two-line sequence of C, E, F, and G, all the elements. So whatever the elements which are present in the brackets, those elements will not be repeated. Now we need to find the frequency or the support count of each items which are present here. For example, here we have C, B. When it is C and B, or it means that what they should be in the different transactions, right? So now I just want to find out whether what is the support count of CB, right? So to do that, I need to find out for CB. So it is not in the basis, means C should be in one transaction, one sequence, and B should be in the other sequence, right? So now let us find C is here. We can find B in this sequence, but it is not in the order. So we'll not consider this. And look at the next sequence. We have C here and B here. The support count starts and the support count will be what? 1. So we don't have any C here and we don't have any C here. So the support count is what? 1. Now we'll have the support count as 1. Similarly, if you want to find for CE, so C should be in one sequence and E should be in one sequence. So here C is in one sequence, E is in one sequence. So the support count will be 1. And here also C is in one sequence, E is in one sequence. So the support count will be what? 2. So in the other, the third and fourth sequence, we don't find the C, E. So the support count is 2 and it is satisfying the condition. So we can take this as a frequent subsequence. So if you want to find for C comma E, so C comma E, they should be in the same sequence. So let us find out whether they are in the same sequence. We can see all the sequence in the, if we scan whole database, we can find C comma, we did not find any C comma E here. So the support count of the C comma E will be what? 0. In this way, we need to find out for all the frequent elements that we have, two-line sequences that we have, and whichever is not satisfying the minimum support rule, all those were eliminated, and which are satisfying the rules that are used to join further to create the third line sequence. So now let us see how to create the third line sequence. So to do that, we'll be taking the continuous subsequences to create the new candidate sequence. What does it mean is, so finally after satisfying the support one, we got the two-line sequence as this. Now we need to create the three-line sequences. And to do that, first let us consider first two elements A, B, and AC. When you take the two elements A, B, and AC, according to the sequential pattern mining, first we need to check for first element of this sequence and the last element of the sequence. So here, when you remove this first element and the last element, the middle element should be the same, right? Here we don't have the same elements. It means that they cannot form the frequent subsequence. Here we have A, B, and B. So if you remove A and E, we can see these are the same elements, right? So it means that A, B, E can form the frequent subsequence. Similarly for A comma B, B comma E, if A and E is similar, we have the same B here, right? But the thing is, A comma B should be in the same sequence. When you are generating the rule also, when you are generating the third and sequence also, it should be in the same, right? Wherever we have the so same sequences that should be considered. So in the next example, if B and G is removed, we can see that it forms the subsequence. But here F and G should be in the same sequence. So that should be clearly mentioned, right? Now, after finding this, now we need to check in the database whether these transactions or the occurrence of these transactions and they are satisfying the minimum support count condition or not. So here in the database, you can see that ABD. AB means what here? A should be in the one transaction, B should be in one transaction, and E should be in one transaction, right? So let us see here. In the first sequence, it is not possible. AB is in the same sequence, so we will not consider that. In the second sequence, A is in 1, B, E. So the support count will be 1. Next, in the sequence, A, 1, B is there and E is there. So the support count will be what? 2. So now whatever we need to find out for all the Italian sequences that are available, and then we need to compare this with the minimum support count. Next, we'll create the four-line sequence. Just like the third-line sequence, we'll compare this with the first and last element. If the remaining elements are the same, then we'll consider that for the frequent subsequence. Or else we'll not consider those elements for the frequent subsequence. And Here in the four-lane sequence, if you look at this, if you try to compare with all the other elements, it is not satisfying. We can see that no middle elements are same. So it means that we cannot create the fifth lane sequence. So we can stop our algorithm here. And so finally, we can say that these are the frequent subsequence which are formed from the given sequential database. Thank you. Hello students, in this video we'll learn about the pattern evaluation measures. So far we have discussed about the algorithms like Appier algorithm, pattern evaluation, sequential pattern mining, and eclat algorithm. In those algorithms, we have seen about the support and confidence, which is used to measure the frequent items. Is that support and confidence is enough to generate the rules that we need to know by the pattern evaluation measures. So here, using the pattern mining, we can generate various set of patterns or rules. But the thing is, whatever the generated patterns or rules, those are interesting or not. This interestingness measures can be of objective measure or the subjective measure. The objective measure is a quantitative measure. It means that we can calculate or we can measure that interestingness using the various measures like support, confidence, correlation, and all. So subjective interestingness measure varies based on the different perspectives. It means that we'll take the reviews from the it may be through the interviews or it may be through the surveys. So based on the situation or based on the perspective of the persons, the interestingness of the applications may change, right? So here, then how to calculate this interestingness measure? So as we have discussed, we have support and confidence, but the support and confidence is enough for us to know whether it is giving us the correct association rules or the pattern rules or not. So let us see this. So actually the support and confidence are used to derive the association rules. So for example, let us consider this example, which consists of a data set of students who were playing basketball and eating the cereals. So here, this table represents the students who are eating the cereals and playing the basketball. So there are 400 students, and there are 350 students who are not playing the basketball but eating the cereals. So from this data set, identify the association rule mining. Suppose that if you want to find out the support and confidence for this, we know how to calculate the support, right? So the union of this play basketball and eating cereal is what 400, right? And total number of transactions we have here what 1000. So we'll get the support count as what 40%. Now if you want to calculate the confidence, right? So confidence here it is given that those who are playing the basketball is what 600, right? Union of play basketball in each serial is what 400, right? So here in the confidence we consider the occurrence of the first element. Suppose if you take this basketball union and the serial, then we'll find the probability of occurrence of this basketball, right? So that is what playing basketball is 600. So you'll get here the value is 400 by 600, which gives you the confidence as what 66.7%. Similarly, if you want to calculate for the not playing basketball and eating the cereal, right? So we'll get the support count as 35, and you'll get the confidence as what 87.5%. Now, if you want to derive some association or if you want to get some statistics from this, we can see that the students who are eating the cereals and playing the basketball is having the highest confidence. In the same way, the students who are eating the cereals and not playing the basketball is also having the highest confidence. So, which may lead to the misleading of the data. And if the owner wants to get any conclusions from this, it might be a little bit confusing, right? So we can say that support confidence framework may not work for the few of the applications. And for that, we are using the other measures which are called lift and chi-square. So the lift, this we have lift and chi-square, this we have already seen in the basic concepts of the correlation, right? So here we'll find the lift using the support count of the, in this example, here B refers to the basketball and C refers to the cereal, right? Union of that and support count of each individual attribute that is present, right? So here, when we calculate this, when you calculate the support of B union C, B union C is what 400 and total number of transactions is what 1000. In that way, we need to calculate for support of B as well as support of C. You got the value as what 0.89. Now I need to calculate for basketball, but who's playing the basketball but not eating the cereal, right? So according to this left, when you got the value as greater than 1, we say that they are positively correlated. When you got the value less than 1, it means that they are negatively correlated, right? So it means that here we can see that it is less than 1. It means that they are negatively correlated. So when you take basketball and cereal, right? So if you are playing the basketball, there might be a chance you are not eating the cereal. In this way, we can get some confusion, right? So here, those are not eating the cereal, but playing the basketball. It means that they're positively correlated here, right? So those are playing the basketball, they're not eating the cell. Right? Two of the things are giving us the same conclusions. Right? In the same way, we can also measure this using the chi-square. Right? The chi-square measure is given by the observed minus expected whole square by
Expected. Here the observed value in the data set is given as 400 and 350. And now we need to calculate the expected value, right? So how will you calculate the expected value? The total sum of the cells and the total sum of the basketball, right? 750 into 600 by total number of transactions. If you do that, you'll be getting this value or expected value. We need to calculate all the expected values for the given data, and then we'll substitute that in this chi-square formula, right? So, and you got here value as what? Some 55.56, so which is greater than 1. And here, it means that when it is greater than 1, we can say that those points are correlated with each other. And to know whether it is positively correlated or negatively correlated, look at the expected values. We can see in the first database that 450 is the expected value, which is more than the observed value, right? So, since the expected value is more, we say that they are negatively correlated, right? So, we have got the same as a lift, right? So, it means that it's giving us a correct predictions. So when compared to the support and confidence, for some applications we can say this chi-square and lift as a good measures, right? So then or only this lift and chi-square are the good measures. For any application, we can use instead of support and confidence this lift and chi-square analysis. No, if you consider any data set like this, you can see in this data set we have various null transactions, right? So it means that those who are not playing basketball and those who are not eating the cereal, we can see the database is showing more transactions, right? So which is not which is very imbalanced, right? So if you're having those values, very imbalanced values, that we call it as what null transactions. Here and when you look at the lift and chi-square for this database where it has null transaction, lift and chi-square will not give you the correct predictions. For that, we need to look at the other measures. So if there is any null invariance or null values in your data, then this chi-square and lift may not give us the interesting measures. Okay. So for that, we have the other measures like all confidence, Jaccard, cosine, and cosine similarity as well as Kulzinski, max confidence and all. Right. So these are the formulas to calculate all of those measures. Okay. And next, and here let us consider a database. Here we have the database like milk and coffee, right? So and when we want to make predictions on this data set, we have D1 to D6, and we can see when there is no milk and no coffee, transactions are more when compared to the people who are drinking milk along with the coffee, right? So these are very interrelated with each other. Those who buy milk, there is a probability that they go for the coffee, right? But it's most of the transaction is showing the negative. So this sort of transactions we call it as what null transactions or null invariants, right? So here, this chi-square, when you perform the chi-square and left, we can see the results are showing wrong predictions, but if there are very low transactions or if there are many null transactions, right? So here, to overcome this, we'll be using the other measures. And if you are calculating the other measures for the transactions which are having the imbalance or the null variant transactions, we can see that Kulzinski is having the sum values. So there is no constant values, whereas the other measures are having different varied values, right? So here, we can say that this Kulzinski holds firm and it has a balance in the both, whether both the implications means if we have low transactions or if you have too many high transactions, then this Kulzinski will provide the better interestingness measures. Along with this Kulzinski measure, the combination of imbalance ratio. This imbalance ratio can be calculated as support, considering the support count of A and B, where the sigma relates to some data attributes which are present, right? So here, divided by S of A, that is support of A plus support of B, and then minus support of A, and B. So we can calculate the imbalance ratio using this formula. And here, when you look at this transaction, we can see that the combination of Fulci and imbalance ratio is giving us a good interestingness measures. So here, D6 is neutral, but we can see very imbalanced, right? So it has very imbalanced data that's not buying the milk, but only coffee. We can see the 10 transactions only, which is not, which might not be the correct transaction, right? So for that, we can see the Kulzinski and imbalance ratio is going to produce a good interestingness measure. So in this way, if we have any imbalanced data or if there are many non-invariant data, instead of using support of confidence or lift or chi-square, this Kulzinski and the imbalance ratio provides us a good interestingness measures. So here we can see that when compared to lift and chi-square, this Kulzinski and imbalance ratio provides us a good interestingness for the patterns. So this is about the pattern evaluation. Thank you.